Good morning, good afternoon, good evening, ladies and gentlemen. Thank you for joining us here. Here on Emergency Management Associates. We're coming to you from the Area Command, 392 miles west of Kitty Hawk Beach, North Carolina. As we've been doing for some time now, we're going to do a salute to the United States of America. We're going to show the United States Pledge of Allegiance and also the national anthem. Would everybody please rise at this time?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now would you make welcome, straight from Washington, D.C., the United States Army Corps Quartet.
Yeah.
Oh, say can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rockets' red glare, the bombs bursting in air,
Okay, I'm sorry I didn't have the volume turned up. I'm sorry, that's my bad. Every time I go on the air here, the stupid YouTube turns down our volume or knocks it off anyway, and I have to put it back up. That's my fault. I didn't recognize that at the time. I'm so sorry that happened. Anyway, guys, I'm going to be talking about earthquakes. I'm going to talk about volcanoes tonight, specifically about the volcanoes and earthquakes in the Pacific Northwest. I'm going to surely show you things you haven't seen that may be very concerning to you, especially if you live in the Pacific Northwest tonight. Down here in the Fiji region, okay, this earthquake here is concerning. This is very concerning. There was also another earthquake that they took down. Okay, it was a much larger earthquake of 5.1 over here in the Kermadec Islands that hit last night. This one hit today. It's a 4.1 earthquake. A 4.1 earthquake out here in the south of the Fiji Islands. However, this still needs to be talked about. Let's show you something else. The depth to the magnitude conversion chart. We're going to look at kilometers here. 526 kilometers deep. It's over here in the center top of the chart here. Okay? 525 to 530 kilometers deep. We're going to add 1.05 to this. 1.05 to the 4.1, which means this 4.1 earthquake that we had today in the south of the Fiji Islands is going to make sure that that's going to propagate, I should say, a 5.1, 5.2 earthquake. It's going to propagate a 5.1, 5.2 earthquake within the next 72 hours to 10 days. 72 hours to 10 days. Okay? Now that could happen. This 5.1, 5.2 earthquake could end up going north. It could end up going south down here into the New Zealand islands down here. It could go to the west over here to Australia. It could go over here into Papua New Guinea where we have this other earthquake here. It could also go over eastbound. Okay? It could go over here to Chile and Argentina. Now you see these earthquakes over here in South America? How about triple those numbers and you'll get to be the right amount of earthquakes that happened today in South America. They're still lying to us through their teeth. We go over here to Papua New Guinea today. Okay? This is a 5.3 earthquake. A 5.3 earthquake that happened yesterday. We reported this yesterday. Folks, they've repositioned this earthquake. This is now on land. It was out to sea yesterday. This is a 5.3 large earthquake, okay? Happening right over in here in the mountainous regions of Papua New Guinea, okay? Not too far from shore, but it was in the foothills of the mountainous region here. There are some villages out here. There are some people that live here, but it's sporadic, okay? This is a third world country. They don't have building codes like we do. Many people live in mud shacks, wooden shacks and stuff like that. There's going to be some damage here, and there's probably going to be some injuries, whether or not we find out about it or not. It's a large quake. Anytime we have a large quake, there's going to be some damage and probable injuries here. And it's probably felt all over this island here. Okay? We've had many earthquakes here in Indonesia before. Okay? Something else that we need to talk about. Down here near Timor-Leste. Timor-Leste here. Okay? This is Timor-Leste. Luotolo volcano has erupted today near Timor-Leste. Let's show you where this erupted at. You take down this map. Let's see here. This is Luo-Tolo volcano. Luo-Tolo volcano. Okay? This is the one that erupted. Just like Semi-Sopokanoi and several other volcanoes around the world. This is a stratovolcano. It's almost totally symmetrical. Okay? It's a beautiful volcano, but it is a very dangerous volcano as well. This volcano has erupted many times. And I've got a story behind it as well. This volcano, like I said, is located in the Timor-Leste region of Indonesia, near the Lesser Sunda Sea here. Okay? Let me bring this over here so you can see it. Okay? See where it says Timor-Leste here? Just north of there in these islands here is where this volcano is. Okay? Wanted to show you that. This is important. Okay? This volcano erupted up to 7,000 feet today. Flight level 700. It was 2,100 meters high. 2,100 meters high. It happened about 22:30 p.m. today over in that time zone. Very huge explosive activity still continuing. The Volcanic Ash Advisory Center says that the ash plume rose up to over 7,000 feet, again 2,100 meters high. Flight level 070. Luo-Tolo volcano is also known as Luo-Tolok. Lewotolok. It's a perfectly symmetrical cone. Is located on the eastern end of the island of Lombok, in the Lesser Sunda Islands of Indonesia. Eruptions here have been recorded since 1600 AD, consisting primarily of explosive activity from the summit crater. Folks, there is magma, or excuse me, not magma, there is lava going down the sides of the mountain. There are people that live here on the island. I believe they have been evacuated for the most part. There's been a lot of explosive activity over here, mostly steam and ash. Today, it's lava going out of the side of the summit crater down the side of the mountain. So this is one of the volcanoes that has erupted down here in the Indonesia area. Now the sad thing about this, folks, is the USGS does not even show any seismic activity here. That's what the sad story is about this. I want to show you something. Okay? Give me a second here. My device shut itself down. Well, not shut itself down, but turned itself off here. And I'm going to be bringing this thing up here so you can see it here. This is the interesting situation here. Okay? I want to show you this. Look at all the earthquakes here. Okay? Look at all the earthquakes in this region. When we have an eruption such as this Luo-Tolo or any volcano, there's usually a 5.0 earthquake that coincides with the volcanic eruption. That's how much pressure that the volcanic eruption puts out. 5.0 large earthquake at least. USGS not showing anything. They're not showing anything in Indonesia today. Let's go back to that. I'll show you. I'm almost embarrassed to show you the USGS map because they literally don't show squat. Okay? I hate putting down this agency because this same agency I considered them a best friend at one time. In my college days, I considered them a best friend. But folks, look at this. They're not showing anything here in the Indonesia region at all. Not a thing. Yet, this is what has really happened over here in Indonesia today. It's incredible. It's incredible. I am floored. I'm pretty much floored because these people don't do their job. They don't do their job, and there are going to be people that are going to suffer as a result of this agency not doing its job. Okay? Just for kicks and giggles here. Okay? These are the earthquakes that have happened today over in New Zealand. Okay? USGS shows nothing. USGS over here shows nothing here in New Zealand. They show nothing in Australia. Let me show you something here in Australia, guys. Okay? Let me show you something in Australia. Good Uga, Australia. A 4.0 earthquake. Good Uga, Australia, a 4.0 earthquake today. USGS doesn't say a word. Down in southeastern Australia down here, the coastal area of Melbourne, Australia, we have a 2.5 earthquake here. A 2.5 earthquake. So we've had a 4.0 to the north and a 2.50 over here in the Melbourne coastal area of Australia. Now, this earthquake here, this earthquake to the north, this is in a volcanic area. This is a volcanic area, guys. This may be the reason for this earthquake as well. I'm going to do some more research on that earthquake. It's very troubling that this earthquake happened early this morning and literally USGS says nothing about it. A 4.0 earthquake and USGS says nothing. Not a thing. They point out 4.0 earthquakes around the globe and USGS says nothing about that one in Australia today. Not a word. The largest earthquake today is over here in China. This, folks, is a 5.5 magnitude earthquake. USGS has downgraded it to a 5.4. It's a 5.5 magnitude earthquake. As they've been doing, they have said this earthquake is 6.2 miles deep, 10 kilometers deep. We don't know how deep it really is. USGS has also said that if they put a 6.2 mile depth, they may or may not be truthfully knowing exactly how deep it is. Sometimes they just throw it up there, just because. Okay? So it might be 6.2 miles deep or 10 kilometers deep. It might not. It might be deeper than that. Okay? It might be deeper than that. This is central China here. Gansu, China. South of there is a 4.6 in Zhejiang, China. 4.6 here, and this is also 6.2 miles deep. We go northwest here, still in China. This is a 4.3 earthquake here, moderate earthquake. 4.0, 4.9 are considered to be moderate earthquakes. USGS has been calling them light earthquakes. There's nothing light about a moderate earthquake. I don't know why they've been doing it. I don't care. Moderate earthquakes cause moderate damage. Not light damage, but moderate damage. Okay? They can call it anything they want, but they're lying to the public. We go down here into Iran, southern Iran. This is a 4.4 earthquake, also 6.2 miles deep. Okay? Yesterday, we pointed out over here along the border area of Turkey and Syria here. There were no earthquakes listed here. There's about 14 earthquakes here today. USGS shows us a 4.2. Isn't that interesting? We can have a 4.0 earthquake over in Australia and they don't show it. Over here in Turkey, they show a 4.2. Again, 6.2 miles deep. I don't believe it. These earthquakes that have happened here in the Turkey, Syria area are aftershocks of a 9.0, 10.0 earthquake that hit here earlier this year. Aftershocks of a huge major earthquake. Okay? Huge major earthquake. Again, over here in eastern Turkey or over here in Greece, they're not showing any earthquakes here. There are about 20 earthquakes over here in Greece and the corresponding area of the Western Mediterranean. Okay? Earthquakes there. Earthquakes here in Turkey. Earthquakes in Romania. Earthquakes in Czechoslovakia. Not showing. Earthquakes in France. Earthquakes in the Alps of Germany and Austria. Earthquakes in the Alps of Italy is here as well. They're not showing them. Why not? Because they don't think they have to. Okay? Earthquakes here in Spain, they're not showing them. Why not? Why not? This earthquake up here in Iceland just happened right before we went on the air today. Okay? Just happened. This is a 5.1 earthquake. A large 5.1 earthquake. This is over here on the Mid-Atlantic Fault. The Mid-Atlantic Fault. You can see that red line cutting through the middle of Iceland here. This 5.1 earthquake is on the Mid-Atlantic Fault here. Now, over to the right from that earthquake, there's a volcano there. There's a volcano to the left of this earthquake as well. And further down there to the south near the coast, there's another volcano there. We've had 2 different volcanic eruptions over here on this peninsula here. I don't remember the name of this volcano here. It almost doesn't matter, but we've had 2 volcanic eruptions from this area so far this year. Numerous volcano eruptions with lava spreading all over the valleys around those volcanoes. It's not a huge eruption going high into the atmosphere, but it is an eruption nonetheless because the lava has come out of the volcano spreading all over the ground. Okay? It's not a huge eruption, but it's still a good sized eruption. It does not go up into the air here from that particular volcano. However, this volcano does. This volcano over here where you see this glacial ice sheet, if it ever goes up again, it'll stop all air travel to Europe. The last time it happened, it stopped all air travel to Europe. Okay? Scientists thought it was going to go earlier this year because of the earthquakes that were surrounding this glacier. It did not happen. It didn't happen. But again, we have a 5.0 earthquake here on the Mid-Atlantic Fault here. That fault goes all the way down through the Atlantic Ocean. Goes all the way down between South America and Africa. Goes all the way down here to the South Atlantic to the South Sandwich Island area. We don't have any earthquakes right here today. However, there are earthquakes that have been here. This is a result of that earthquake up here in Iceland today. As we are going westbound, let's make a stop over here in the Caribbean area. Okay? This is Puerto Rico. The largest earthquake here today is over here near the U.S. and British Virgin Islands. This is a moderate 4.0 earthquake here. This is 72 miles deep down into the asthenosphere. The asthenosphere is down below the crust of the earth. Let me give you some information about that. Okay? Hold on just a second. I want to raise this up just a little bit. Okay, let me give you some examples here. Okay, the crust of the earth that we walk on. The crust of the earth that we walk on is about 39 to 79 miles deep. 39 to 79 miles deep. This earthquake over here near the U.S. and British Virgin Islands, This is 72 miles deep. This is down in the asthenosphere where the plastic magma is. The plastic magma. Okay? This is why that earthquake hit. There's magma down here. There's magma down here. Why do you think these islands were made? Because these islands had volcanoes. They still do. And occasionally we get a volcanic eruption down here in the lesser islands over here. What is it? Oh, I can't remember. Martinique. This is probably one of the most famous volcanoes down here. It erupts all the time. USGS does not have a really good picture of this volcano, and I don't know why they have not updated it. But this volcano took off and erupted last year. Not a huge eruption, but erupted last year. Okay? Anyway, getting back over here, again, a 4.0 earthquake happened over here in the ocean around the U.S. and British Virgin Islands here. Over in Puerto Rico, we have this earthquake here. It's a 2.0 earthquake near Salinas, Puerto Rico. We've had numerous other aftershocks here in Puerto Rico. Aftershocks because, folks, 4 years ago we had two major earthquakes. 8.0 on December 26th and an 8.4 on December 28th. As a result of those major earthquakes, we're still getting aftershocks here. This here is a 2.5. This is a 2.8 here. This one here is a 2.4. Okay? This earthquake here is a 2.6 near Guanica, Puerto Rico, where my friend Dominic lives, who's the captain of the Puerto Rican police force there. Okay? This is a 2.7 here. This is the same area where those 8.0 and 8.4 earthquakes hit. All over this place, it shook like they've never seen it shake before. It caused major damage here. Major damage. Right here at this seaside city here, there was a huge sandstone arch, typical of an arch that you might see over in the Utah Arches National Park. It was along the seashore here. The 8.4 earthquake hit here. It finally took down that arch. It was a monument arch. Okay? Monument arch. They actually had it as a historical event here. And that earthquake took it down. These earthquakes were man-made. I've talked about it before. Those earthquakes were man-made, causing major damage. Buildings shaken, torn apart. Homes torn apart. Lives torn apart. People killed and injured here in Puerto Rico because men that decided they were going to light off, and I'll show you this really quick here. They thought that they were going to light off an experimental machine right here. Please don't put this in the chat. I don't want this put in the chat because YouTube might take us down. Okay? But this organization right here triangulated from Norway, Russia, and also over in northwestern Australia, and took that arch down as well as damaged this area, and it's continuing to shake. Aftershocks. Kimberly Hopkins just gave us another $5 super chat. Thank you, Kimberly, for that. God bless you for that. We really appreciate it. It means a lot to me. But anyway, that's what's going on here in Puerto Rico. This earthquake further off to the east, I don't believe this earthquake has anything to do with these aftershocks. This is completely separate here. This may also have to do with magma down beneath the surface here. Magma down beneath the surface. And if you look, guys, look where these earthquakes are happening. Okay? The seismic energy and the lava goes out to the east. out to the east. You might ask, why, Ron, does it go out to the east? Let me show you where this lava, magma, originates. Okay? Down here deep in the South Pacific, there is a huge lava plume going down into the deepest parts of the earth. That lava plume goes up into the crust and is disseminated through lava channels all around the world. It's disseminated through lava channels all around, magma channels I should say, all around the world. Okay? Down here. In this case, that magma is going out to the east. It's going out to the east. That's why it's flowing out there. Okay? I believe that's why those earthquakes hit. This earthquake here, let's take a look at this. This is over in the South Pacific off the coast of Chile. This is a southeast of Easter Island. Easter Island is over here in this region right there. Easter Island's here. Southeast of Easter Island today we had a 4.7 earthquake here. On the southern, I believe it's called the Southeast Rise. The Southeast Rise here. This is 6.2 miles deep. How many more earthquakes are we going to have here where USGS is calling them 6.2 miles deep? That's never happened before. We've never had this many earthquakes originate and they call it 6.2 miles deep. It's never happened before. Okay? Never ever. Now I want to show you something when we come to talk about South America here. Okay? I'm only going to show you this just briefly. Okay? Again, they're showing us 5 earthquakes here in South America. Can you triple or quadruple that? Look at that. Earthquakes all over this region, guys. Look at these earthquakes. Earthquakes all up and down this area. I just spread it out just a little bit just so you can see it. Look at all these earthquakes. They're showing us 5. What a crock of crap that is. Okay? Down here near Valparaiso, Los Chiques, Biobío, Chile, a 3.5 earthquake. Most of these earthquakes are 2s and 3s here. Most of them are 2s and 3s. As we go north, 3.6 in San Juan, Argentina. Atacama, Chile, 3.8. 4.0 in Londres, Argentina. 4.0 in Londres, Argentina. Londres, Argentina, folks, is over here, right there. It's in the Andes Mountains here at the border of Chile and Argentina. Londres, Argentina, a 4.1 earthquake there. There are a total of, I'm going to get it here, we've got a total of 2, 4, 6, 8, 10, 12, 14, 15, 18 earthquakes. There are a total of 18 earthquakes here in South America. USGS shows us 5. What a crock of crap that is. Going north into Peru, Arequipa, Peru. A 4.0 earthquake in Arequipa, Peru. Arequipa, Peru is home to an astronomical observatory, a radio observatory here in Arequipa, Peru. Okay? North of there, still in Peru, central Peru along the coast, it's a 4.7 earthquake. A moderate 4.7 earthquake right there. 4.7 earthquake. Folks, they're saying this is 34.8 miles deep. 34.8 miles deep. Right there. Okay? Going north, there's more earthquakes than that. Ecuador. This is a 3.5 earthquake in Ecuador here. 3.5 earthquake there. Into Colombia. Colombia, northern Colombia, guys. Northern Colombia, we have a bunch of 2s here. This is a 2.8. That's a 2.8, guys. These other earthquakes around it, another 2.8, 2.7, and a 2.6 here. This is a 2.6 here. Okay? Now, USGS is showing us an earthquake off the coast of Panama. This is a large 5.0 earthquake here. We've seen other 5.0 earthquakes in this same region along the Cocos Fault here. Along the Cocos Fault. Okay? The Cocos Fault is a plate boundary here. The plate boundary. We're having earthquakes along the plate boundary. Okay? Tectonic plate movement. Okay? Now they're not showing any other earthquakes here in Central America, are they? Not a thing. Look again. There are earthquakes there. They're just not showing it. Okay? In Central America, Costa Rica. Costa Rica 3.2. Okay? Northern Costa Rica a 3.6. Northern Costa Rica 3.6. Nicaragua, off the coast of Nicaragua, there's a 4.1 here. Right next to it, just north of there, also a 4.2 earthquake here. So 2 4s off the coast of Nicaragua. Then we go north. El Salvador, a 2.6. Now, the only earthquake, and my map comes from the European Agency. The only earthquake that we show in southern Mexico is one. Okay? 19 miles south of Atoic de Alvarez. Okay? Off the coast of Mexico. A 4.1 magnitude earthquake off the coast of southern Mexico. Now, I don't know. Okay? I'm just a messenger. I do not know what they're doing here or why they're doing it. We've had upwards of 30 to 40 earthquakes here in southern Mexico in the past. All of a sudden, about a month ago, they shut them down, both on the USGS map and also on the European map. It may be personal or purposely done. I believe it's probably purposely done, because these people don't want us to know what's going on. There's plenty of seismic energy moving north into northern Mexico from southern Mexico. Plenty of it. One of these days, and we've seen energy coming up here through the Gulf of California into California itself. The Gulf of California is this stretch of water between mainland Mexico and the Baja California. Okay? This is also the San Andreas Fault, the southern part of the San Andreas Fault. And we've seen 5.0, 5.1, 5.2 activity coming up this region through the San Andreas Fault up here into the Gulf of California. Today, and I'm going to cover this in a few minutes, okay? Down here. This is Puebla, Mexico. Puebla, Mexico. This is just south of the U.S. border, okay? This is a 2.3 earthquake, 9.3 miles deep, okay? Then we come up here to Holtville, California. What have I been telling you about Holtville, California in the past? Okay, we mentioned this last night. I had a speech and debate contest down here in Hopeville High School. Okay? There's also another thing down here as well, having to do with seismic energy. There's a seismograph here in Hopeville. Okay? It's at the Salton Sea Desert Research Station here in Hopeville. Holistic Nurse Griffin just gave us a $10 super chat. She says, thank you for being honest with us about all this activity. Love your heart for others, brother. Truth and God bless. Thank you so much, Nurse Griffin. I appreciate that. God bless you for that. But folks, down here, this seismograph over in Hopeville is recording these earthquakes here. This is a 2.7. This is a 2.5. This is a 1.4. This is a 1.4. And this is a 1.8. Okay? Earthquakes over here in Hopeville, guys. Earthquakes over here in Hopeville. There are a lot of other earthquakes here that are not being reported either. Okay? Now, why do they do this? Why do they report some and not others? That's a good question, because I'm going to show you in about a half hour, I'm going to show you a lot more earthquakes than this. A ton of them. A ton of them. About 150 earthquakes up here just south of the Salton Sea today. And even more at Bombay Beach, over on the center east side of the Salton Sea. Okay? For now. And yes, we have earthquakes here in San Diego too. Okay? This is Bonita, California, just south of San Diego City. Bonita, California. Okay? They say this is a quarry blast. They're full of crap. Okay? They're full of crap. Let's take a look at where this quarry blast hit. It's not a quarry blast. It's a 1.1 tremor right next to a major roadway here in Chula Vista, California. Now, I don't remember what that highway is. I have a feeling I know what it is. But this is a 2-lane highway going north and south here through Chula Vista. Yet we have a tremor here that they're calling it a quarry blast. They're full of crap. Okay? Again, they don't even look and see where the earthquake is, and they just call it a quarry blast. What a bunch of crap is that? To the north here, this is Ramona, California. Ramona is just north of Poway, California, where I used to live. Ramona, California here is a 0.9 microquake. A 0.9 microquake. Now, folks, the deal is this, okay? Ramona is the first time I've seen an earthquake here of any kind. We've had earthquakes down here in Poway. Okay, let me bring up Poway here. Okay, this is Poway, California, where I used to live. Okay, in fact, let me show you where I used to live. I used to live in this housing development. Okay, right down here in Poway, California. Right? I used to travel up to Ramona all the time. I have good friends that live in Ramona, California here. My dad built a church building in Ramona, California. Okay? So I have good ties and good feelings about Ramona, California. We've had other earthquakes going north and east. This is Lake Henshaw, northeast of Escondido, California. I used to go fishing at Lake Henshaw. I used to go fishing here at Lake Henshaw here. We have a 1.2 tremor right here, just north of Lake Henshaw. Further north here, this is Palomar Observatory. Palomar Observatory, guys. This is where the telescope is. Okay? A 0.8 microquake here. This is on the Elsinore Fault. The Elsinore Fault is this seismic range. You can see it just to the bottom of Palomar Mountain here. Okay? I have a story if you guys want to hear my story about Palomar Mountain. It's a very significant story to me. But anyway, that's another story here. As you can see, there are other earthquakes here in Southern California, specifically in the Anza Gap here, Anza Borrego Desert State Park. One other earthquake over here. This is a quarry blast over here near Home Gardens, California. Near Home Gardens. This may be even a quarry blast, okay? This is not far, probably a half mile to a mile north and east of the Home Gardens quarry here. Okay, so this may in fact be a quarry blast. Go figure. Almost every earthquake that we ever had here in Home Gardens has never been a quarry blast. It's actually been an earthquake. So this is another first for USGS for calling that right. Okay, north of there, Port Hueneme, California. We've had numerous earthquakes here over the past 4 years. This is a 1.0 tremor off the coast of Port Hueneme. Okay, notice these islands. Okay, the Catalina Islands here. This is an earthquake fault here just off the coast of Port Hueneme. That's why this earthquake hit. There's a fault zone just off the coast there. Okay, let's go north. Specifically, I want to talk right now about this earthquake here, just off the northwest coast of Vancouver, British Columbia. This was a moderate 4.5 earthquake. Again, it's a moderate earthquake. This is 6.2 miles deep again. I call bushwa on that. Okay? Grace for purposes. Story time, please, Ron. Do you guys really want story time real quick? Because I'm going to come back here regardless and talk about the Pacific Northwest. As you can see, there's plenty of earthquakes to talk about here. Okay? You guys want a story time? We'll talk about it. Okay? Rob is also talking about another 4.5 earthquake here off of Port McNeill. Port McNeill off of Vancouver Peninsula here. Just another earthquake. Not surprising. Not surprising at all. Anyway, you guys want a small story here. I spent a great deal of time on Palomar Mountain over the years. I had a scouts troop. This is Temecula, just on the outskirts on the north side of the San Diego County, Orange County line. Temecula, California with the 1.0 tremor here. This is also on the Elsinore Fault. Okay, let's go back down here to Palomar Mountain. That's Lake Henshaw. This is Palomar Mountain right here. Okay. Kristen is asking, is it time to leave Lincoln City, Ron? I don't believe so. Okay? I don't believe there's anything happening more dangerous or less dangerous right now. I wouldn't move right now. Okay? I just wouldn't. I won't tell you to move. I will never tell you that at all. I will never tell you that. Okay? Anyway, guys, I'm going to briefly talk about Palomar Mountain here. Okay? This is an area here that's near and dear to my heart. My scout troop came up here many times, venturing out in the wilderness here. Yes, at the top of Palomar Mountain there's an observatory, a great big huge famous observatory there. But there is also camping areas here, a lot of camping areas. Okay, hold on a second. I want to show you something here. Number one, One of the reasons I'm going to show you this one thing here at Palomar Mountain is my dad built what I'm going to show you here. Anyway, this is where Palomar Observatory is. I'm going to show you some more definable pictures of Palomar Mountain. These restrooms on Palomar Mountain my father built. He was a masonry contractor. He was asked by the people at Palomar Mountain, the Forest Service and such. This is a national forest, by the way. But he was asked by the forest people to erect this campground restroom facility. And so he did. Over at the observatory, guys, there is a dome that protects the telescope. I'm going to show you that next. There's a asphalt trail that leads from the campground all the way up here to the telescope and the associated buildings with the telescope. There's about 6 buildings here. Okay, if you guys are getting buffering, you might want to go out and come back into the broadcast. That usually ends the buffering, and I'm sorry you're getting buffering. Well, I'm sorry, okay. This is the observatory, guys. This building, this dome houses the Palomar telescope. Okay, it houses a telescope here. The restrooms that my dad built, and I'm sorry I was not able to show you those, it's right here. Now let me do this. I'm going to bring that over here. These buildings my father built. Okay. I found it a great privilege to work with my father, and a lot of people did. I had a great time working here at Palomar Observatory with my father. I had a good time camping here as well. Okay, let me show you this. This was a camping area. Oh geez, it's too big. Hold on. This is those restrooms that my father built. It's a huge camping area here at Palomar Mountain. Okay? Huge camping area. During the summertime, the astronomers hold astronomy weekend, and people bring up their own fellow made or homemade telescopes, and there are other telescopes people bring up here to look at the stars here, because up here at Palomar Mountain it's rather shielded from the radiation from the lights down in Escondido and various other places in San Diego County. Palomar Mountain is a great place to watch the stars, the planets, and everything else here at Palomar. Anyway, guys, not too far from this restroom facility, off to the left here, there's a grove of trees and bushes. There's a large rock there. I came up here with my parents when I was a kid. I was a teenager, about 16, 17 years old. And the whole purpose of coming up here to Palomar Mountain that weekend was to gain a testimony of Jesus Christ. That was the whole purpose. So we were told that we could go off by ourselves or stay in the camp facility that we had set up there. It was a bunch of tents. We could stay in the campground area, or we could go off on it by ourselves, and that's what I chose to do. I took my scriptures over here to this rock that you can't see here in this particular photograph. I sat on the rock for about 4 or 5 hours reading my scriptures and praying. This was my first solid testimony that I got about the divinity and truthfulness of the gospel of Jesus Christ. That I have found out that night, that evening, that Jesus was the Christ, the Son of the living God. That was my experience on Palomar Mountain. It's a very sacred experience that I shared here with you. Okay? A great thing. Now, I didn't mean to share that with you today, but since there was an earthquake there at Palomar Mountain, I decided to share it with you. Okay? You've seen Palomar Mountain, you've seen the observatory now. One day I may show you the other parts of the observatory as well. Anyway, guys, I want to show you some other pictures here of earthquakes around the volcanoes as well. Over on the USGS map, I showed you earthquakes that USGS said that happened over in the Pacific Northwest, Washington, and Oregon. I'm taking you now to Mount Baker. This is a seismogram from Mount Baker. This is the main page seismogram from Mount Baker. Okay, now I'm going to enlarge this so you can truly see what we want to show you here, so you can understand what's going on. MBW is the code for this main seismogram page here at Mount Baker. You can see other earthquakes here. Up at the top you see some vertical lines, long vertical lines here. There was an earthquake last night. An earthquake here at Mount Baker last night. As you can see, there are other earthquakes here as well. This earthquake here in the center part of the photo of your slide here, this is about 1 inch long, right? Maybe a little over 1 inch. Look at the secondary wave of that earthquake. Okay, it sticks out probably about a minute, maybe a little more than that. Okay, it's hard to see because it's so small here. What I'm trying to show you here, and so is that other earthquake in blue up here to the right as well. Okay, this happened last night. This earthquake in the black happened about 10 minutes after 12 midnight. This earthquake in the blue happened at about 11:30, actually 11:44 this morning, or last night, 11:44 last night. However, look at this magma churn signal here. See this red signal here? This what they call a magma churn signal, guys. Let me enlarge this for you, and we'll show you what we have here. Magma churn signals typically are 23 to 24 lines long, meaning top to bottom. This magma churn signal is 1, 2, 3, 4, 5 lines high. The little red rectangle is what we're looking at. 5 lines high. Typically 23 to 24 lines high. Folks, this is less than 1/5 of real world. 1/5 of real world. The lines out to the right of that magma churn signal are steam coming from Mount Baker. Mount Baker often steams. I have people that call me. I have people that write me emails and send me messages telling me about Mount Baker and Mount Constitution, which is south, about 40 miles south of Mount Baker. Okay? Mount Baker is steaming. Given that this magma churn signal is showing 1/5 But what it should show, this earthquake here at the center of your slide here right now, this is probably a 3.5 earthquake. A 3.5 earthquake. That earthquake here with that long line that you see, guess what? That was probably a 5.0 earthquake up here at Mount Baker last night. A 5.0 earthquake last night at Mount Baker. Okay? This is a seismogram coming from the Pacific Northwest Seismic Network. Okay? It's the only seismogram we can pull up from Mount Baker. USGS will never have, I don't think they will ever have, a seismogram that shows Mount Baker at all. They haven't had for 4 years, 4.5 years I've been doing this. They're not probably going to start now. And this is not the only one I'm going to show you. Let me show you a couple others from Mount Baker. This is important. This one is very important. Okay, this is Mount Baker Shuxon. This comes from this seismograph at the ski resort on the north side of Mount Baker. Okay, Shuxon. This is a multi-channel seismogram. Or seismograph. Multi-channel seismograph. A seismograph is a machine. The seismogram is the document that the seismograph records for us, showing seismic activity. In this case, this activity here is VOF waves. The VOF waves are caused by magma entering the volcano. Magma entering the volcano. Look up at the top of this seismogram here. Okay? Look at all that activity here that happened last night. We show you that other seismogram showing the earthquake that happened just before 5 p.m. Just before 5 p.m. yesterday. Okay? This one is recorded at 5 p.m. here. So that long line that you saw on the other seismogram, that was probably an earthquake that happened at around 4 p.m. yesterday afternoon. A 5.0 earthquake. Okay? Look at the lines that are all together here, up at the top of this seismogram. That's a lot of activity. That activity probably caused that earthquake yesterday afternoon. Look at the earthquake activity here. Okay? Last night after 10 p.m. 2200 hours on the left. You see 22 over on the left? That's 2200 hours. That's 10 p.m. last night. Look at all this activity between 10 p.m. and 4 a.m. this morning. All that activity is a lot of magma coming into this volcano. Look at that. And that activity continued until about 2 p.m. today. You can see it waning just about 1:30. You had a lot of magma coming into Mount Baker until about 2 o'clock today. That is an awful lot of magma coming into this volcano. Okay? That's Mount Baker. Now, I want to show you Glacier Peak. USGS and the Pacific Northwest Seismic Network covered Glacier Peak. However, they turned it off. They turned the seismograph off at Glacier Peak. It's now been turned off for about a month. Why are they doing it? Who knows? They're supposed to be installing 5 more seismographs on Glacier Peak. Glacier Peak has been showing, up until this time, has been showing several earthquakes a day. Some of them as large as 3.5, 4.0 earthquakes at Glacier Peak. We don't know what's going on at Glacier Peak. They're not telling us. When we have seismic information, we'll tell you about it in Washington at Glacier Peak. Okay? I'm now going to show you Mount Rainier. There is a lot of activity at Mount Rainier. Okay? I think you might be surprised at what we're going to show you here. Look at this. Folks, this is Camp Sherman. This is on the north side of Mount Rainier. Look at all this activity. The thicker the lines, the more magma coming into the volcano. The thinner the lines, the lesser magma that's coming into the volcano. Each horizontal line here is representation of 15 minutes of time on the seismogram. The top of the seismogram started off at 9 p.m. last night. Started off at 9 p.m. last night. You can see what happened. Now, you see that blue horizontal rectangle, or not horizontal, vertical rectangle here, over to the right. Okay? That again is a magma churn signal. This time on a USGS seismogram. Okay? This magma churn signal, like I said, is typically 23 to 24 lines high. Let's count this. 1, 2, 3, 4, 5, 6, 7 lines high. Folks, this is less than 1/3 of what it should be. So, if we want to look at this seismogram here, when we see earthquakes, imagine these earthquakes 3 times the size that they are. There is an earthquake just to the bottom right-hand side of this magma churn signal. Again, the magma churn signal also has some lines to the right, meaning steam coming from Mount Rainier. Steam being generated from the magma. Okay? Steam being generated from the magma. We have an earthquake here. Just looking at it, this might be a 2.2, 2.3 earthquake. Multiply times 3. All of a sudden, this would be a 3.0 earthquake easily. Easily. Now, let me turn this off here really quick. We'll come back to it. I want to show you what happens with that magma and the steam. Okay? Every volcano has a summit to the volcano, doesn't it? At the summit is a great big huge rock. A great big huge rock that keeps the magma from flowing out of the volcano, right? Absolutely. Folks, when the volcano last erupted, the lava cooled. The lava is coming out of the volcano, and then it slows down and stops. The lava cools and leaves a summit rock, a rock plug in the volcano. A great big huge rock plug in the volcano. What happens? Okay? The magma is coming up from underneath, and it's pounding against that rock. It's literally pounding against that rock inside the volcano. That rock gets hit and hit and hit over and over and over again. The magma comes up and hits on the bottom side of that plug. Pretty soon, between the heat of the magma beneath that plug and the pressure that the magma is exerting on that plug, it causes holes to develop. These holes develop as a result of the pressure and the heat coming from the magma. Okay? Holes develop. Pretty soon, the steam that's coming from the magma comes out of those holes, doesn't it? The steam comes out of those tiny holes in the plug of the volcano. The heat of the steam also enlarges those holes, doesn't it? And the magma is still pounding on the bottom of that plug, which is creating larger and larger holes. At some point in time, that huge plug will pop. The huge volcanic plug at the top of the volcano will pop because of the pressure of the magma from underneath and the steam that comes through those holes in the plug. Steam, hot steam, enlarges those holes. Hot steam enlarges those holes. When it gets bitter cold at the summit of some of these volcanoes, maybe there's not as much steam coming out because those the cold tightens those holes down. If the holes are large enough, they'll still put steam out even in the middle of the winter. I've seen it happen. Now, what you also might need to know for those people that are here that are new, okay? What you're going to see, what you need to know about this magma underneath inside the volcano. 6 to 7% of the magma is water. 6 to 7% of the magma is water. That magma is operating at a temperature about 2,000, 2,500 degrees, sometimes as hot as 5,000 degrees. That's pretty hot. So you have this magma smashing on this plug of the volcano, right? You have this magma smashing on the plug of the volcano. It's exerting pressure on that plug. It's smashing into that plug, causing fractures to develop. Fractures developing. And all of a sudden, we have that water turning into steam, and that steam exiting the volcano in the form of steam coming out from the top summit of the volcano. Some steam exits from the sides of the volcano as well. We've seen that happen. We've seen this, the sides, the flanks of Mount Rainier that let loose a bunch of ice and snow about 3.5 years ago. I showed a video at the time it happened. Great big huge mass of ice and snow, rock and trees and other things fell off the side of the volcano. Interesting thing about that, when it happened, USGS, the National Forest Service, denied it happened. I had a video I showed on the air. 2 weeks later, the Forest Service finally admitted that it happened. It was lahar. A lahar is caused by glacial ice, water, and snow coming down the side of the volcano. It came down not just the side of the volcano, down the streams that were on the side of the volcano, and came down and destroyed trees and roads in the area that had to be repaired. Isn't that interesting that this would happen? They would deny it happened, then all of a sudden they'd have to acknowledge it. Okay? They had to finally acknowledge what had happened. It's crazy, guys. It's total lunacy that they would not even admit that it happened until I showed the video. Somebody had a video and put it out on the internet, and I showed it. Very few other people had even seen that video. I put it out on the air, and I had over 5,000 views that night that I showed it. It's insane. It's really insane. So anyway, let's get back to this, to Mount Rainier here. I want to show you what's going on. These horizontal lines, guys, is showing them the magma coming into the volcano. This is called magma pulse signals. Magma pulse signals. Magma PULSE signals. Okay? They get thinner, thicker, and then get thicker again. Thinner, and then get thicker again. The thicker lines are showing magma coming into the volcano. When you see so much magma coming in, you see more earthquakes as well. The more magma you have coming into the volcano, the more earthquakes and tremors you're going to get. Why? Because the magma coming into the volcano, folks, is coming in under pressure. It's fracturing rock inside the volcano. That fracturing rock is earth movement. Earth movement. And the fracturing rock also causes the volcano to rise. Volcano movement. Uplift. Volcano uplift. Okay? And as you can see, there's a lot of magma coming into this volcano. A huge amount of magma coming into this volcano. Look at this. You see these other vertical lines here? These larger or longer lines are earthquakes that are happening. And you can see by that magma churn signal I showed you here, This is only showing maybe 1/3, not even 1/3 of what is real world. So if you multiply these, the length of these lines times 3, you know it's not just a 2.2, 2.5 earthquake. These are 3.5, maybe even close to 4.5 earthquakes here at Mount Rainier. I can prove it. I can prove it. Look what's going on. There's so much activity here at Mount Rainier, it's not funny. It's not funny at all. Look at this earthquake here. Okay? Folks, this earthquake happened earlier today, earlier this afternoon. Okay? It's incredible. It happened just after 3:40, well, actually, it's about 3:56 p.m. this afternoon. Look at that earthquake. The top and the bottom of this earthquake have been cut off. They don't want to tell us how strong this earthquake is. However, let's look out to the right of this earthquake. This earthquake lasted probably 30 seconds. Out to the right, we have a secondary quake. A secondary quake. What does this mean? The secondary quake lasts a certain amount of time, doesn't it? That secondary quake looks like a triangle. The secondary quake lasted over a minute. This earthquake, folks, was at least a 4.0 earthquake this afternoon at Mount Rainier. A 4.0 earthquake here at Mount Rainier today. Today. Okay? Then this afternoon we also had another magma churn signal. Most of the time there are 2 magma churn signals on every seismogram. If there's one, there's usually a second one not that far behind, usually before the end of the day. Here is another one here. Okay? Just showing you what is going on here at this volcano. Mount Rainier is a very active volcano, regardless of what they want to say on the USGS map. Rarely do they ever share exactly what is going on. Rarely ever. Okay? That's why I show it to you, so you guys will know what's going on. Now there's more than this happening. I promise you there's a lot more than this just happening here. It's getting late here. I'm going to have to start showing you some more activity here that's going to blow your mind. Okay? Let's drop down south to Mount St. Helens. Mount St. Helens here. Okay? I want you to see this. Okay? Again, this particular seismogram started at 2200 last night, 10 p.m. last night. Okay? You can see the magma coming into this volcano and clumps of magma as well. Okay? This seismograph has been turned way down. For instance, here's another magma churn signal. Okay? Very thin horizontal or vertical line here. Very thin rectangle here. This one lasts 1, 2, 3, 4, 5, 6, 7. This again is 1/3 of real world. Meaning everything that happened here today at Mount Rainier, you multiply times 3. Okay? And probably a little bit more than that. Okay? Probably a lot more than that. Okay? You see a small earthquake here that happened just about 6 a.m. this morning on the left here. 0600 on the left is 6 a.m. this morning. Grace for purposes, did I miss Alaska? I didn't talk about Alaska yet. Okay, I did not go there yet. Okay? Over here this afternoon. Here is another, or actually this morning. This happened just after, I want to say, 11:56 a.m. this morning. 11:56 a.m. This is at Mount St. Helens. Okay? This seismograph has been turned way down here as well. This right here, if it was real world, would show a 2.2 earthquake. Again, we look out to the right. Okay, the secondary wave of the earthquake, okay, forms a triangle here. It goes out almost a minute later. Okay, that means this earthquake was a lot stronger than it's showing here. Not just a 2.2 earthquake, probably closer to 3.5 earthquake. Right there. Okay, then we go on just after 3 p.m., 1500 hours on the left-hand side, we have another minor tremor, possibly a low-grade 2.0 earthquake. However, guess what happened here? Okay, this shows this earthquake to have happened after 4:30 p.m. It's not. In this particular seismograph, this seismogram shows it at 16:30, after 16:30 hours here. This would be 1:30 this afternoon Pacific time at Mount St. Helens. Look at this earthquake here. Okay? Are you amazed about an earthquake of this size happening at Mount St. Helens today? After about 1:39, 1:40 p.m. today. They cut off the bottom and the top of this again. This earthquake lasted 2.5 minutes. This earthquake lasted 2.5 minutes. Folks, this is a 5.0 earthquake. I believe this is a 5.0 earthquake at Mount St. Helens. Why do I say that? Look off to the right. The secondary wave lasts nearly 2 minutes by itself. The secondary wave goes out about 2.5 minutes. This earthquake was a very large earthquake. At least a 5.0 earthquake. They cut off the bottom and the top of this, meaning they're lying to the public. Richard Smith says this is a nasty earthquake. Yes, it is. And yet USGS doesn't show it. The USGS map does not show this. Look at the other seismic information we have after this earthquake hit. Look at the amount of magma. Each line, each horizontal line is 15 minutes long. Look at the amount of magma coming in each line here. There's an awful lot of magma here. Okay? Then at the bottom of this seismograph, over here at the bottom, folks, we have a magma churn signal here that we do not have total comprehension of, because it's on the next seismogram coming tomorrow. Over here. Here is the magma churn signal here. 1, 2, 3, 4, 5, 6, 7 lines high. Multiply 3.5. 3.5 on top of the height of this earthquake. This is a 5.0 earthquake. There's no doubt in my mind this is a 5.0 earthquake at Mount St. Helens. No doubt in my mind. With this magma churn signal here, oh yeah. This was a 5.0 earthquake at Mount St. Helens today. Now, I'm going to leave this seismic signature here. I want to show you the earthquake map. This is what really gets me. Okay? They want to tell us, oh, nothing's going on. They would have us believe that nothing is happening here. Really? They want us to believe that nothing happens here. Folks, you can't believe them. They're not showing any activity here at Mount Rainier. I just got through showing you the earthquakes and tremors that are happening here at Mount Rainier. Over here to the northwest here is Carbonado. There's actually a seismograph here at Carbonado. They say this is a 2.4 earthquake here, a minor earthquake at Carbonado in the northwestern foothills of Mount Rainier. This earthquake over here, Coppeson, Washington, a 2.0 earthquake here. Okay? This is west of Mount Rainier, and I already showed you all the activity we had at Mount Rainier. This is Mount St. Helens, guys. They're not showing diddly squat here at Mount St. Helens. This seismic signal is a 0.4 microquake. A 0.4 microquake on the southern flank of Mount St. Helens. This earthquake here is just below the summit on the southwestern flank of St. Helens. This is a 0.1 microquake. This is 3.5 miles deep. This seismic signal here is 6.3 miles deep. 6.3 miles deep. They're not showing the 5.0 earthquake or any of the other earthquakes here at Mount St. Helens at all. This tells you what I've been saying about this agency. They're lying through their frickin' teeth. Heaven forbid they can tell us the truth about what's going on at these volcanoes or anywhere else. They don't know the truth at all. They can't tell us the truth at all. Now, this is Mount Adams. Mount Adams is east of Mount St. Helens here. Okay? I'm briefly going to show you a seismogram from Mount Adams. Rarely do we ever get to see anything at Mount Adams because they lie about it. They cover it up. They cover it up. Then we will be going to Mount Hood. You see some activity at Mount Hood? Guess what? There was activity at Mount Hood today. They're showing a 1.6 tremor. A 1.6 tremor at government camp. Folks, this earthquake was not at government camp. This was near the summit of Mount Hood. This is like Palmer Ridge, or excuse me, Palmer Lift here at Mount Hood. This is not government camp. USGS says it's government camp. It's not. This is more like Palmer Lift. It's a 1.6 tremor. But I'm going to show you more earthquakes here at Mount Hood as well. Okay? Over here to the southwest, Woodburn, Oregon, a 1.4 tremor here. Okay? That's all they're showing. That's literally all they're showing here. There's a lot more energy here in the Pacific Northwest than that. They can't tell the truth. They don't know what the truth is. I'm convinced of it. I'm convinced of it. This seismogram here showing you a large earthquake here. They can't even admit to exactly how strong it is. They cut off the top and the bottom so they will not be able to show you how strong that earthquake was. What a bunch of crap. Okay? I know why they're doing it. We all know why they're doing it. It doesn't make it right. They should be telling people how strong these earthquakes are. I can't wait to have somebody here that was there that tells me how strong they felt this earthquake was. Okay? I notified my friend Laura Marie that lives here in Oregon. She should be able to tell me what's going on here. Yes, this was in southern Washington at Mount St. Helens, but she may have felt shaking here. This was a strong enough earthquake here at Mount St. Helens. They may have felt that shaking down in Oregon as well. So folks, let's continue on here. Okay? Let's go over to first Mount Adams. Okay? This is a seismogram from the Pacific Northwest Seismic Network here at Mount Adams today. Usually they don't show us any activity. Because I've not been covering Mount Adams a lot, because they don't show us anything, they have now given us some information at Mount Adams. This seismogram is also not showing us exactly how strong these signals are. I believe they turned down the seismograph on this one as well. All we're seeing are tremors here at Mount Adams, except for down here this afternoon. Okay? On this red line here, this is 2:15 p.m. this afternoon. Okay? Over on this left-hand side here, bottom left, this would be a 1.8, 1.9 tremor. Okay? I believe it's probably a 3.0 earthquake at Mount Adams. Okay? Look over here to the right on this same line here. Okay? This is about 2:25 p.m. this afternoon. 2:24, 2:25 p.m. this afternoon. That, if you look at it by itself, is a 2.8 earthquake. Multiply that times 3. I believe this is probably a 3.8 earthquake at Mount Adams today. Okay? This is the first time in quite a long time we've had any real verification of earthquakes at Mount Adams, because after I started talking about it, they took them down. Heaven forbid they let anybody know what's going on. Now let's go down to Mount Hood. Mount Hood is very active. Look at this. This is Barrett Spur on the north side of Mount Hood. Okay? Barrett Spur was a volcano in and of itself at one time. Barrett Spur right now is a huge volcanic field. Volcanic rock. Excuse me a second, guys. I don't know who that person was, so I turned it off. Okay? Anyway, this is Barrett Spur. This is Barrett Spur on the north side of Mount Hood. This is a lot of information here. Okay? I don't know who that guy is that's calling, or I might even put him on. I just have no clue who he is. And I don't put on people that I don't know what's going on. I'll talk to him privately. If he wants to come on the air and talk, we can do it another time. I'm just not going to put him on the air tonight. Anyway, folks, this is a big deal. Okay? Mount Hood is busy. Look at all the magma flowing into Mount Hood today. That's an awful lot of activity. That is a great lot of activity here at Mount Hood today. You can't look at this and not realize what's going on here. I've been doing this for a very, very long time. Very much a long time. And to look at it any other way, I'd be wrong in doing it. Let me open this up and show you something. The vertical lines here, if they do not have a dot in the middle of the vertical line, that would be steam coming from the volcano. Okay? These vertical lines with steam, these vertical lines with a dot in them, those are tremors and earthquakes. The red lines are generated by the computer. Not mine, but the USGS computer. So the USGS seismologist will say, oh my gosh, let me look at that. That's why the computer alerts the seismologists about what's going on. These are earthquakes that are happening. Okay? Look at all these earthquakes here. Some of them are just tiny tremors. Tiny tremors. But there are earthquakes here at Mount Hood. There are earthquakes happening here at Mount Hood. Okay? Let me show you another seismogram from Mount Hood here. It's called Timberline. Timberline. Timberline is government camp. Timberline is government camp. Look at this. USGS shows almost nothing going on. Almost nothing. The seismograph starts recording information at 2200 hours last night, 10 p.m. last night. You see magma coming into the volcano here. These lines are very thin. The seismograph that was recording this was turned way down. Way, way down. There's no way a normal seismograph set up with normal settings would show this much activity with these thin lines. If this was true activity, these lines probably would not have any white on them because there's so much activity here. There's a lot of magma coming into this magma chamber at Mount Hood. This is the southern side of Mount Hood at Timberline Government Camp. Okay? Look at this. It's not showing us any activity. Why? Because they've turned it down. Normally these vertical lines, horizontal lines, you'd see a lot of vertical lines showing tremors. But the thing is, the seismograph is so far turned down, the tremors are having a hard time even making its way through the electronic turndown of the seismograph. Down here at the bottom, you can see evidence of that. Okay? I believe these signals are strong enough to probably be 1.0 tremors. Well, actually, there's already here showing 1.0 tremors, but they're probably 2.0 earthquakes at the very least. At the very least. This seismograph has been turned way, way frickin' down. Okay? It's insane. It's insane. Joseph Mengele here in the chat says all the magnitudes up, divide by USGS, and you get 53.17 upside down. Okay? Anyway, that's what's going on here, guys. USGS playing games with us. All these volcanoes are very active volcanoes, regardless of what USGS says they are, or even the Pacific Northwest Seismic Network. Already we've proven what has been happening here in the Pacific Southwest. Mount Hood being busy, Mount St. Helens having a large earthquake today. You saw the seismograph. Seismograms don't lie. USGS maps lie. USGS maps lie. Okay? I'm going to show you briefly Sisters Volcano going south. Okay? Sisters Volcano going south. This is it. This is the only seismogram that we can pick up showing Sisters Volcano. Notice all the crap that's on this seismogram. These horizontal boxes here. These horizontal boxes are crap. Okay? It's called artifact. Artifact. It doesn't mean anything here. Not a darn thing. Why USGS is doing this, or the Pacific Southwest Network doing this, who knows? But it's not showing real activity. The other activity here is these horizontal lines. These thicker horizontal lines showing magma coming into the volcano. Sisters Volcano is actually 3 volcanoes. Sisters North, Sisters Central, and Sisters South. Look at what's happening. We're actually having tremors and earthquakes here. Sisters Volcano. Okay? There's a lot of activity here, and they're passing off a bunch of abstract here. Who knows why? This is stupidity on behalf of the agency, or on behalf of the, what do I want to say? It's stupidity from the agency. Plain simple. We go south from there to Newberry Volcano. Right here. Newberry Volcano. Again, this seismograph has been turned way down. That's why we have all these thin lines. We're showing tremors here. Probably earthquakes here at Newberry Volcano. Look what happens this evening. Look what happens this evening, guys. This is important. Look at all the earthquakes hitting here. Look at all the magma hitting here. Okay? There's a lot more activity here than is showing because the seismograph has been turned way down. Normally I would think that if the seismograph was turned back up where it should be, full bore, you probably would not see anything but blue here at the bottom. Why am I saying that? Let me show you one other seismogram coming from Newberry Volcano today. Look at that. This is a different seismograph. It's recording what's going on. This is cinder cone at Newberry Volcano. Again, the thicker lines here are showing absolute magma coming into the magma chamber here. That's a lot of magma. Completely obliterating the white of the paper. It's incredible. Now, I am saying paper here. This is actually digital. These are digital signals. They're no longer paper drums like we used to have. I'm sure there are some drums still running, but this is all digital now. Okay? But still, you see what I'm talking about. That's an awful lot of magma coming into Newberry Volcano. Okay? A ton of it. Literally a ton of it. Now, I'm going to go further south to Crater Lake. Why? Because we're running low on time here. And I want to get through a lot of information here. Crater Lake bunkhouse. Look at this. This is on the center south of Crater Lake. The center south of Crater Lake is where this seismograph is. Look at the activity here. Again, the seismic now the seismograph has been turned way down. Way down. But again, what do we have here just after 2:55 a.m. this morning? We have another earthquake here. Another earthquake. In this case, this lasted at least 2.5 minutes. But they've also cut off the secondary wave. They've cut off the secondary wave. Earthquakes don't end just like this. Boom, gone, done. It doesn't happen. There's always a secondary wave here, and they've cut that off. They cut off the bottom, and they cut off the top to us. We go further down here on the seismogram. Again, this is Crater Lake. Look at the earthquakes here. Okay? At 8 o'clock in the morning, on the lighter blue line here, we see some tremors, don't we? And one on the right that's probably close to a 1.9, 2.0 earthquake. But how about this box over here to the right? Okay? This would be after 8:15. Over here on the right-hand side, we're talking about 8:25 a.m., 8:26 a.m. this morning. Look what we have. I've never seen a signal put up on a seismogram like this. Never. This means they messed with it. They cut off the bottom and the top of it. This is Crater Lake. There is a huge lake at the top of the volcano. I would say, folks, that this is probably close to a 4.5, 5.0 earthquake. Okay? Look at this one here. Again, there's a box here. That doesn't normally happen. This does not normally happen. And then another box this afternoon down here. Look at all this magma here. Even when they messed with the paper here. And the stylus went up when it was trying to record activity here. That happened after 5 p.m. today. Look at that. This is 5 p.m. Eastern Time, not Pacific. Okay, that was probably 2:45 p.m. Pacific. It's incredible. It's insane. Look at all that magma there. There is no small wonder that we have some good-sized earthquakes here, and they're not telling us how strong they were. They're cutting it off. That should be a crime. For those of you that have not been with me before now, I am a retired federal police officer. I worked for the federal government. If I had submitted false documents, false police reports, I would be in jail right now. I would still be in jail right now. Not retired, not living in my house, living in a jail cell. These folks, these seismograms are false data. They have been altered and manufactured to show exactly what they want to show and nothing else. This is a felony. This is a felony, guys. This is a major crime. Kimberly Hopkins says she has a lifelong buddy that lives right near Crater Lake. That's cool. I would love to know if that buddy of yours has felt any of this activity. This is insane. This is insane. Now, I want to show you quickly, I'm going to go south to Mount Lassen. Okay? I want to show you activity at Mount Lassen. Okay, I'm skipping over Mount Shasta tonight just because. Look at all this activity at Mount Lassen. Look at these earthquakes here. Okay? This seismogram started recording activity at 2 p.m. yesterday afternoon. Look at all these earthquakes and tremors yesterday afternoon. Some of these earthquakes are 4.0 earthquakes here at Mount Lassen. Then they turned down the seismograph. They turned down the seismograph, and there's very little activity making it through the turn down. The electronic turn down. Then, all of a sudden, we have this earthquake activity again. Look at this. Look at that. Look at these big earthquakes. Again, the red streaks here are the computer that's getting the attention of the seismologists. Look at this. This is important. That's why they use these red styluses on the seismogram. Look at this one on the right, these earthquakes on the right-hand side. I believe these earthquakes are at least 4.5, 5.0 earthquakes at Mount Lassen, California. California, guys. Tomas S. and Demon Catman, autumn solstice is hitting on the Central European plain. Wouldn't be surprised. Wouldn't be surprised. Guys, please hang in here with me. Pay attention to what we're talking about, please. Okay? We can talk about the European solstice in a little while or tomorrow. I don't think we'll get to it today, but tomorrow we can talk about it if that's what you want to do. Again, this is Mount Lassen volcano. Mount Shasta is just as busy. I can promise you Mount Shasta is just as busy. Now I want to go over here to Mount Hood. Not Mount Hood, I'm sorry, Mammoth Mountain. I want to show you what is going on at Mammoth Mountain. I have many seismograms I could show you, but I'm going to show you this just for time's sake. Okay? Look at this activity. This looks like a lot of the other seismograms showing us very little activity and then cutting it off where there's no activity at all. Typical. Typical of the USGS. Look at here. Okay? This seismogram started off at 3 p.m. yesterday afternoon at the top. Look at the tremors here. Look at the tremors here. Over on the bottom right-hand side center here, we have some tremors that may be larger earthquakes there, depending on how strong this seismograph is turned down to. Okay, look at this. All of a sudden, this morning, the seismogram starts showing a lot of magma coming into the magma chamber here. These thicker lines show a lot of magma coming into the magma chamber, and as a result, we see more and more earthquakes here at Mammoth Mountain. Look at that. Mammoth Mountain is very busy, and I could show you about 4 other seismograms showing the same kind of activity all over Mammoth Mountain. This is over in East Central California, by the way. East Central California is where Mammoth Mountain is. Out east is a volcano called Long Valley Volcano. Before I show you seismograms at Long Valley, I want to show you a movie here. A very short story, about 4 minutes long, at Mammoth Mountain. Okay? This you're going to want to see. This is about 4 minutes and 15 seconds long. This eruption isn't at
A California
Long Valley.
supervolcanoes that has the power to bury Los Angeles in more than 3,000 feet of ash is showing signs of activity. Scientists at the California Institute of Technology identified more than 2,000 earthquakes occurring across the Long Valley caldera in recent years. The team conducted a new investigation to see whether the seismic activity was a sign of impending catastrophe or whether the risk of a major eruption was decreasing. California Institute of Technology researchers created detailed underground images of the caldera and found that recent seismic activity was caused by fluids and gases released as the area cooled and settled. Study author John Wenzon said, "We don't think the region is poised for another supervolcano's eruption, but the cooling process may release enough gas and fluid to cause earthquakes and small eruptions." For example, in May 1980, there were 4 earthquakes measuring 6 on the Richter scale in that region alone. An important finding with the image reveals that the volcano's magma chamber is covered by a layer of hardened crystallized rock, formed when molten magma cools and solidifies. This long-dormant volcano was the site of a super explosion 767,000 years ago, which released 140 miles of volcanic material into the atmosphere and devastated the land. John Wenzon and his team placed dozens of seismometers throughout the eastern Sierra region to capture seismic measurements in a process called distributed acoustic sensing. They traversed 62 miles of the caldera with cables to take underground photos. Over a year and a half, the team used the cable to measure more than 2,000 seismic events, most of which were too small to be felt by humans. Emily Montgomery Brown, a Long Valley caldera expert who was not involved in this research, told the LA Times that a wave of earthquakes began in 2011. These earthquakes were then followed by ground deformation that caused the ground surface to rise, and the shaking subsided in 2020, so that the area becomes calm. But he warned an eruption was still possible. A 2018 study found the Long Valley caldera holds 240 cubic miles of magma beneath its surface. And even if the Long Valley magma reservoir is nearly dead, there are still other pockets of magma in the area, Montgomery Brown said. If the caldera erupts, it would surpass the Mount St. Helens explosion in 1980, which only ejected 0.29 cubic miles of volcanic material into the atmosphere. In fact, the 240 cubic miles of magma stored in the valley is enough to fill 400 million Olympic swimming pools.
Now, folks, this is not live magma pouring out of the volcano at Long Valley. This is just simulated or showing you what would happen if Long Valley volcano erupted. Okay? That's why I want to show you this. This is real. Okay? It could happen. It could very well happen. What I want to show you now is activity at Long Valley volcano. Okay? That's where I'm going to show you right now. Look what's happening here at Long Valley volcano. Okay? This is over on the, what shall I say, the west side of Long Valley. Long Valley volcano, guys, the caldera is 23 miles wide. 23 miles wide. There are some scientists that say that Long Valley and Mammoth are connected. That would possibly be true. It could possibly be true. And if it is, guess what? Mammoth Mountain would be in the Long Valley caldera as well. Then we would have the Long Valley caldera being 75 miles wide. 75 miles wide to encompass Mammoth Mountain. As the scientists said here that put this video together, there's 249 square miles of melt. 249 square miles of melt underneath Long Valley volcano. Some of that is solidified, but not all of it. Okay? 249 square miles of melt beneath the volcano. As you can see, it is very active here. Now let me widen this out to show you exactly what's happened today. Look at this. Okay? Like I said, this is over on the western side of Long Valley. Look at this earthquake at the top. This happened yesterday afternoon. Yesterday afternoon, just after 3:32 p.m. This appears to be a 4.5 earthquake at Long Valley volcano. But again, USGS does not show it on the USGS map yesterday. They're not showing any of this. Okay? The only way you're going to find out is if you go after the seismograms to see what exactly is happening. Okay? Yesterday evening. Okay? This next earthquake here looks to be at least a 3.5, 3.8 earthquake. Could be a lot larger than that. It didn't last that long, so I would probably stick with a 3.5 earthquake at least. Okay? This happened just after 6 p.m. yesterday evening. Okay? About 6:08, 6:09 p.m. yesterday evening, a 3.5 earthquake here. The one over here at the top left, you can see out to the right. Okay? That's why I say this is probably a lot larger earthquake here, probably 4.5, 5.0 earthquake at least here. Why? Because we have this secondary quake here. This secondary wave out here. Seismic energy continuing after the main shake. Okay? We can only see pretty much only the bottom part of this earthquake. The secondary wave shows us that this earthquake is a lot stronger than what they're showing us here. Okay? Then we continue to go down here. Look at these other earthquakes here at Long Valley. Okay? This one here after 9, I want to say this is about 9:40 a.m. this morning. Okay? Again, this is about a 3.4, 3.5 earthquake. Before that, we have a 2.0, 2.2 earthquake. Down here, the one on the red line over here on the right hand side in the dark blue. This happened after 6:30 a.m. this morning. Okay? Just about 6:43 a.m. this morning. This earthquake here. You can see the buildup to the left of it. Tremors building up into the earthquake. Then we see the main earthquake here. Then we see the secondary wave off to the right. Again, this is probably at least a 4.4, 4.5 earthquake, judging by the secondary wave to the right. Okay? Look at these other earthquakes here as well. Those are good sized earthquakes as well, guys. That's Long Valley. That's Long Valley. USGS wants to play this game showing nothing going on the USGS map. You have to get in and look for the seismic activity on the seismograms. This is the only way that you're going to see what is going on, is to go to the seismograms and find out. Okay? That's an awful lot of activity. I want to thank Rob for hooking me up with that video. He sent me that early this morning, and I thank him for that. I wanted to share with you guys as well. That will show you exactly what the scientists think of Long Valley Mountain, Long Valley Volcano. Okay? Surgery is probably working this evening. You guys asked about Heather. Heather sent a message out earlier saying she didn't feel well. So we want to send our prayers and love to Heather, and our prayers that everything is good with surgery's work. He works in a very, shall I say, dangerous occupation that could possibly put him in danger. He's not in danger all the time. Nathan Hester is asking what was the seismic, not seismic, what was the location of that video? Hold on just a second, I'll give it to you. It was on YouTube. It was on YouTube. After our program is over, I will post the location of this video for you so you guys can go look at it yourself. It was on YouTube. Rob gave it to me earlier today, and I appreciate that. Does anybody have any questions about anything we've shown you? I have one further seismogram to show you, and that is from down in the Imperial Valley, okay, over at Calipatria, okay. I showed it to you today. I'll show it to you again tomorrow when we talk about Southern California, okay. This is Calipatria, okay. Again, the top of this was yesterday. The top of this seismogram was yesterday. Look what's happening, okay? It started off after 3 p.m. yesterday. Then, just after 8 p.m., they shut off the seismograph. Shut off the seismograph totally, okay? From 8 p.m. on. About 8:05, 8:07 p.m. on to this morning. Let's take a look at it, okay? They didn't turn it back on until 7:30 this morning. Nearly 8 hours, 7.5 hours, they turned the seismograph off. USGS, what are you trying to hide? This is a USGS seismogram. What are you trying to hide, USGS? Why are you doing this? Inquiring minds want to know. Why are you turning off the seismograph over and over every day? This has been happening for several months now. Look at the earthquakes this afternoon here. This morning going into this afternoon, there's a lot of seismic activity here. Let me erase this up for you to see. There's a lot of seismic activity here, yet they don't want us to see what happened all night. Okay? There are probably close to 80 earthquakes here at the bottom. Calipatria, this is just south of the Salton Sea. Just south of the Salton Sea. I showed you earthquakes here yesterday. Okay? Up here, we probably have close to 40 earthquakes here. Total over 100 earthquakes here today. Last night and today. If they had kept the seismograph on all night long, there would probably be close to 150 to 200 earthquakes here together. Why are they turning it off? Inquiring minds want to know. USGS, call me. Send me a letter. Send me an email and tell me why you're turning it off. Inquiring minds want to know. This is not just this seismogram here. It's other seismograms here as well that we showed you tonight. Why are you turning off the seismographs? We want to know why you're turning them off. Richard's going to night-night. Thank you for being here, Richard. Richard's up in Nova Scotia, Canada. It's 9 p.m. there, 9:15 p.m. there as well. It's getting late. Guys, do you have any questions for me? I know I've spent a lot of time here today. I meant to spend that time with you today as well. I wanted to make sure you had the information here that you needed to have. We haven't shown a lot of stuff here in the Pacific Northwest at all lately. We've been too busy with other things. But you can see there's plenty of earthquakes happening, along with a 5.0 earthquake at Mount St. Helens. That's very telling of what's going on there. Mount St. Helens could be ready to erupt right now. It shows everything ready to erupt at Mount St. Helens, and it might very well do that. Now, I want to share a scripture with you before we leave here tonight. Okay? This comes from 1 Corinthians chapter 13. Several verses here, starting with verse 2. And though I have the gift of prophecy, this is Paul talking, though I have the gift of prophecy and understand all mysteries and all knowledge, and though I have all faith, so that I could remove mountains. If I have charity, I have nothing. If I don't have charity, I have nothing. And though I bestow all my good to feed the poor, and though I give my body to be burned, and have not charity, it profiteth me nothing. Verse 4. Charity suffereth long, and is kind. Charity envieth not. Charity vaunteth not itself, and is not puffed up. Verse 6. Rejoice not in iniquity, but rejoiceth in truth. Verse 11. And this is where it's really important here. I believe Paul is talking to us all. Verse 11. When I was a child, I spake as a child. I understood as a child. I thought as a child. But when I became a man, I putteth away childish things. Verse 13. And now abideth faith, hope, and charity. These three. But the greatest of all these is charity. Brothers and sisters, that says a lot. Faith, hope, and charity, and love, with an eye single to the glory of God, qualify us for the work. Faith, hope, charity, and love. Please remember those scriptures. Please remember those scriptures. Those are important for each one of us. Our lives are such today, our lives are in turmoil. Our world is in turmoil for the most part. Let's go back to the beginning. Let's start off right. Faith, hope, charity, and love. with an eye single to the glory of God. Qualify us for the work. I hope you guys have had a good night tonight. Thank you for being here with us. So far we have 122 thumbs up, which I greatly appreciate. If you have not already given us a thumbs up, please do so before you leave tonight. Also make sure you check your subscriptions. YouTube keeps unsubscribing people here on the program. They're suppressing all of our vital information. They don't want people to be here. They don't want to attract attention. Please join this show. Please join us here on YouTube. When you do that, also click on that little bell icon. There's a tiny bell icon. Click on that. That will get you notified when we come on the air. Click on the word ALL, all. Hopefully that will get you notified when we come on the air. Those people that are seeing that they're not being told when we come on the air, go out, unsubscribe, and immediately resubscribe. Then click on that notification bell and you should be notified when we come on the air. Don Patoka tells me he has to do it 2 or 3 times a week sometimes. That's the way to do it. Folks, I love you. I care about you. Grace for purposes. Thank you, Ron. My most favorite time, sharing scriptures at the end. Much blessings and love to you and all. I love you all too. I enjoy sharing scriptures and sharing things special to me as I did tonight. I admonish all of you, like I did up at Palomar Mountain when I was a kid. Go someplace that's special for you, where you can be alone. Study the scriptures and pray. Find out for yourself who Jesus Christ is. Find your own testimony of the gospel of Jesus Christ. You will be blessed, and your family will be blessed for you doing that. May God be with you this day and always. I appreciate each and every one of you here. I thank you again for being here. Folks, if anything else happens tonight, we'll be back here on the air to tell you about it again as soon as the information becomes available. Until then, have a great night, guys. God bless. Be safe. And we'll see you the same time tomorrow, sometime after 6 p.m. in the evening, Eastern Time. God bless you all. I love you all. And thank you all for being here. Carl Smith says he just resubscribed. That's great. God bless you all. Thank you so much. See you soon.